That's there, connected. Working. And this is here. And we can put that over there. Look at this. I even got the projectors working today. Isn't that wonderful? All right, what great time for some maths. Okay, let's see here. We should have here through Esmeralda. Six, seven, so you guys can here. Like that. And let's get started. Good afternoon, everybody. Hello. Happy New Year. Hope you all had a wonderful break. Mine was pretty good. I got a lot of stuff done, not as much as I wanted, but I also got a lot of rest in, which is important too. So let me wrap up the attendance here. Just make sure everyone here. Melissa. Esmeralda, Jackie, Anthony, and Sylvia. Yep, okay. Everyone that I'm actually expecting for today. Got to redo the thing because Power School treats the new semester like it's a whole nother class, so I got to reorganize it all again. That's okay. Today, we've got what I hope to be an interesting discussion. Okay, we are going to dive into the very essence of mathematics itself. Okay, I've been thinking about this for quite some time, for my own understanding, as well as to be able to share it with you. What is math? What's it all actually about? How can we better understand what this thing is that we're learning all of these bits that fit into it? What's the baseline? What's the big picture? Okay, and so you have for today a handful of discussion questions to go along with that. Those will relate directly to the reading over break, the mathematician's lament, okay, about the nature of math and contrasted with how it's generally taught in schools. Right? There's some of that we can't really get away from, but I'd like to at least try to introduce some different viewpoints. And then I have my own understanding from thoughts and research that I would like to share with you. So all you need to do for today is answer those 6 questions there on Google Classroom. Now, before we go there, though, let me draw your attention to an email I sent yesterday with some reminders and some updates. There's some changes happening for this semester. I want to make sure we're all on the same page, just kind of remind ourselves what the expectations are, okay? So, the class schedule with the rotating color days ends up with 2 required days to report in, right? One on your scheduled color day, where you come either here in person or there on Zoom, and then again on Friday, as much at least as we do have Fridays, it's not every Friday, reporting on Zooms exclusively, okay? That's required for attendance. Now, expected for the class, in order to work with and understand all the material, okay, you need to experience the class every day, even on those off days where you're not here in person or Zoom. And you can do that either by watching live on YouTube, okay, that's up and running. Hello, YouTubers. No, the person making the video would be the YouTuber. That would be me. You'd be viewers, okay. Hello, YouTube viewers, right? You can watch that live, or you can watch it, the recorded version, you know, at a later time. Say you got a doctor's appointment or something that day, and you can just watch it later whenever You get to it, that's just fine by me, so long as you do watch it and complete whatever associated classwork, either some questions to go with it or a short problem or exercise or something, right, that is the classwork for the day. Just get that done on that day, I'll be happy, okay? Doesn't matter what time of day. Now, beyond that, right, each class will have its activity of the day, as well as each day will have a homework assignment, right, an exercise set, right, the typical math problems that you take home and work on, or if you're already home, something to do later. Okay? There's the class time now, then there's the break, you go do your other classes, and then afterwards. So it is important that you have those like 2 separate instances in the day to think about these things. Pausing and coming back helps your brain. So there's that assignment. Each week we will have the writing activity. There's a topic, a little prompt for you every Monday. That's due by the next Monday. You'll probably write it over the weekend, that's fine. Every weekend you will be reading and taking notes. You'll be reading the next section of the textbook information and taking notes on that ahead of time so that next week during class you'll be able to ask me questions about it. Okay, if you're reading and you're not quite understanding, some people, they can just read the thing and be like, oh yeah, I get it, I've got it, I'm good, I'm set, and they can just finish the homework right there. Others, maybe that book doesn't do it for them, it doesn't explain it very well. So that's your chance to be like, not quite. And then you come back, and you write that down, you ask the question in class, and now I can clarify with you in real time or over email, right? If it's not your color day, ask away, and we can get that cleared up. That is the best way for you to understand the material, get that double dosage of it, as it were. Related to that, the quizzes that we did mostly weekly, right? Those are still returning, except I'm moving them to Mondays. Every Monday, except this one, from here on out, right, following your textbook reading and notes, every Monday we'll have a quiz that serves sort of as a reading quiz, just to kind of hold you to that, but it also serves as a reflection for you to see what you're missing. How well did you understand it just from the book? And what parts do you need to pay extra special attention to during the week, maybe ask some more about? And then, of course, because we started it on Monday, the retake you can finish by the end of the week, and so you'll have more of that week. You'll have the whole week to get that done. I know a lot of people, if the quiz came out on Thursday and then they got busy and, oh no, ran through a lot of late quizzes there. Now you'll have a whole week to get that in. All right, similarly, SAT practice, I'm going ahead and still assigning that. I'll put that on Thursday morning, but that'll be due Monday instead of from Wednesday to Friday. So you still have multiple days on it, but now it's over the weekend, just to offload some things from Friday. A lot of classes, a lot of stuff, everything was due Friday. So I tried to lighten that a little bit for you. In addition, the greatest lightening of the load will be removal of, for your class, study.com. Right? It was a great resource. I love the online instant feedback. You can immediately check and retake the things. But it was quite the load of just total work and then having yet another website that you had to check and go to, and it was more headaches than I think we were really getting out of it, so I'm just dropping that. We're just going to stick to the straightforward problems and book reading and from that single source for this semester, okay? Now, that said, the lengths of the remaining assignments have been fitted accordingly. It's not like, oh, now we have half as much homework. Like, not quite. I will talk more on that specifically tomorrow about how long assignments will end up being, because I'm introducing a level system, and you'll be able to kind of customize how much you want to engage with each assignment depending on your availability, okay? Next item, the master schedule. I need to remind you of this. It is a super awesome Google Sheet you have access to straight from Google Classroom please, please, please look at it. Check it often because it tells you when we're doing everything. If you want to know, hey, what's the topic for tomorrow? What are we talking about next week? It's all there. That is literally where I do all of the course planning. As soon as I figure out what we're doing when, what the homework will be, I put it right on there. So as soon as I know, you can know. You just have to look. Okay? So use that to your advantage. And final note there, Fridays, still kind of a grab bag because we don't have every Friday. There's, because of the work schedule and then various holidays and days off, I can't count on that happening every week or even every other week. So some Fridays will just be a regular class lesson kind of day. Some Fridays will be some kind of assessment, another quiz, or maybe the test might fall on a Friday. I'm going to try to avoid that, but it could happen. And other days, we'll make it fun. We'll play some more math games, okay? Those are still very valuable to me. They get you to think in different ways, expand your mind in new directions, all right? And that's all of those items addressed. Any questions from you on such things? Seeing and hearing none, then let's go back to the topic at hand. What is the nature of math? How does it all go together? Where is this coming from? Why does Mr. Apple spend so much time on what the heck is math itself instead of just getting down to the nitty-gritty? Well, because you need to build in that foundation, okay? If you're building anything, okay, you've got to make sure it's on top of something solid. So this comes from a lot of my numerations on teaching these classes, how to better understand it so that I can present it to you. And I would like to just kind of share with you what I've found from my own internal thought process, from my own learning experience, and from direct research into these ideas, onto what is mathematics, what is mathematical thinking, what does it take to actually solve problems, which is going to be a huge part of this semester. If you take a look at the quarters for geometry, they're on the master's schedule. Quarter 1 was called logic. Quarter 2 was SAT geometry. So that's where we had just the list of the geometry facts, and here's the formulas and all the things you need to know. Okay, it's rather a short list. I was kind of surprised that we could basically fit it into a quarter. It's a full quarter. But we'll revisit a lot of that material when we apply it in quarters 3 and 4 to problem solving. Okay? So yeah, here are the bigger problems, the bigger issues. How do we use those little bits to solve bigger bits? What does that all mean? So here's what I started with. What does it mean to actually think? It seems kind of arbitrary, but you have to start there. If you're going to be working with math and thinking with math, you got to start at the very basics. What does it mean to think at all? Thinking is not just the recalling of facts. Okay? Your mind does work very much like a library. It stores a bunch of information, and you can work through and retrieve it. You can browse the shelves, pull out a book. Oh, here's a book on, medieval history, and here's one. You have the fact, 2 + 2 = 4. That's stashed away in there somewhere. Pulling that out and saying, here's this fact that I know. Just regurgitation of facts is not thinking. That doesn't require thought. Okay? And if you take a moment, you will realize that, yeah, that's true. That doesn't require effort at all, right? To just bring that forward. 2 + 2 = 4. You know that. That's a fact by itself. That's one idea. True thinking about something is to put ideas together, multiple ideas. It's forming combinations, okay? Different combinations, new, unique things, and seeing what happens. It's like performing a little experiment inside your head. Well, what if we took the 2 + 2 = 4? What about that idea? And then 4 + 4, what's going to happen now, right? When you're first learning addition and you learn these rules of addition, and it's like, okay, does that rule now apply to this number? And what about this number? Does it always work? What's the consistency? What's the pattern? Okay? Finding those things out, that's the thinking. Now, related to that is the nature of problems. Problems are things you encounter in the world that almost force you to think, right? It's an obstacle to overcome. But I would say there's a difference between a problem and an exercise, as I've often said in class, right? I'll assign you exercises. Those are just practice. Those you know how to do. Here's the formula. Here's a set of numbers. Apply the formula. Plug the number into the formula. Done. Plug these numbers into the formula. Done. Plug these numbers into the formula. Done. It's rote. It's repetitive. At some point, you start to think, well, this is kind of boring. This is really tedious. I'm just doing the same thing over and over again. I know how to use the formula, okay? But what you're doing there in the repetition is just like literal exercise, okay? Lifting weights, all that repetition builds the muscle. You get stronger, you get better at it. It does, okay? What a problem is it's some new combination of exercises that you haven't encountered before. Right? An exercise you know how to do. It's only an inconvenience to you. It slows you down a little bit, but you'll get over it. You're not worried about it. When the light bulb in your desk lamp burns out, you're not worried about it. You're not concerned, like, oh no, what am I going to do? You don't panic. You know how to change the light bulb. You go to the closet, you get the new bulb, unscrew the old one, screw in the new one, done, right? Easy. But a problem is a new combination of inconveniences. Every problem can be broken down into components. Okay? Changing the light bulb on my desk lamp at home is simple. That's an inconvenience, it's not a problem. If one of these light bulbs here at school burns out on me, here in the classroom, okay, we've got these big, long lights, some kind of fixture. I'm guessing they're those long tube incandescents, but it's a completely enclosed box, so I can't actually see the shape of the bulb. So one, I don't know what the bulb itself looks like. I don't know that. I can't see it. I don't know where we keep the extra bulbs. Okay? It's way up there. I can't reach it in the first place. So at first I'd have to get a ladder. I got to find out where we keep the ladders, then find out where we keep the light bulbs, right? Or maybe I shouldn't do this myself. This is a building thing. I should find the guy who's in charge of maintaining the building so I could find the guy and ask him about it. I don't know where he is. Do I even know who's in charge of the light bulbs? Do you know who's in charge of the light bulbs at school? Right? Like, that's another issue. If you already know that, it's not a problem for you. That itself, finding the guy who's in charge of the light bulbs, is an inconvenience, right? Finding the ladder. If you know where the ladder is, go get the ladder, bring it here. Inconvenient, but very doable. Right? If you know where the light bulbs are, go get the light bulb, bring it here. Very doable. But if you don't have all of those things yet, this new combination, all of a sudden I got to do this and this and this, you start having this whole list of tasks that add up to the problem solving of change the light bulb at school. See the difference there? And so it brings me to a related idea that often comes up in such discussions, is the nature of intelligence. And a lot of people like to say they're bad at math, or so-and-so is really good at math. And I disagree. I don't think there's such thing as good and bad at math. There is only a difference in speed. Okay? You will solve the problem eventually. Eventually you'll get that light bulb changed, one way or another. Either you'll do it yourself, okay? You'll take the time, you'll hunt down the ladder and the light bulb, or you'll hunt down the guy who knows how to change them, and you'll ask for his help, okay? Asking for help is totally a solution to the problem. There's, I have heard of these people that live these lives and they live at home, they don't know how to change their own light bulbs, but they know who to call to change their light bulb. They're like, I don't need to worry about that. I know the guy. I can call the guy to come fix it myself, or call the guy to fix it for me, right? That's a solution, perfectly valid, okay? And so there's lots of different ways to solve these problems. Some people are able to solve them quickly, okay? I've seen intelligence defined as the ability to solve problems, and that's generally what they use on an intelligence test. If you take an IQ test, they test supposedly your ability to problem solve. But what they don't tell you is it's really not whether you'll solve it eventually or not. It's a question of how quickly you got there. Because if they gave you all week to take the intelligence test, right, you'd pass with flying colors. It's like the difference between taking the MAP test and the SAT. The map test, you got infinite time. Our scores in this school, fantastic on the map test. You guys take your time, you do amazing at it. The SAT, though, you got a lot less time. Suddenly there's pressure. You're like, oh, shoot, right? It's not that you don't know it, that you won't get there. It's a difference of speed, okay? So don't let this idea of intelligence, being smart, dumb, okay, being good or bad at math, don't let that get you down. Don't focus on that, okay? Difference of speed. How do you get speed? Practice. That's all it is, right? Remember those exercises. Once it becomes an exercise, you do it over and over again, repeat, so you get better at it, so you get faster at it. That's how you get more intelligent. You practice mental exercise, so you get faster at it. And when you're faster at it, it seems like you're able to think these new profound thoughts. No. You're just way quicker at trying all of the different combinations until you find one that works. That's the only difference. So that brings us back to math. Mathematics as a class requires intelligence. We're putting a lot of different ideas together. And the nature of math is such that it applies to a lot of different fields. Okay? It's really unique in that you can look and find the mathematics in every other subject, right, at school. There's mathematics there in the science classes. That one's probably pretty obvious. There's mathematics hidden in English class, okay? Have you ever heard of iambic pentameter? Have you studied Shakespeare yet? Poetry, rhythm, patterns. That's math, right? Patterns is mathematics, okay? History, full of maths, names, dates, years, time, okay? Comparison of army sizes and shapes, okay? There's mathematics inside there. And so it's really hard to pin down what is math at its essence when it's so broadly applicable. We see it everywhere. I've got to encompass so many different ideas and still be able to think within that given framework, right? I've got to have a definition of math that can be used also in history, also in science, also in English, but still stand out as its own thing. That is a tough task, right? We got pretty close at the beginning of the year with this bit, the one-word math classes. And I had you read through this, and he found a one-word definition for each of the math courses. Right? Algebra is the mathematics of relationships. Geometry this year is the mathematics of space, or you might say mathematics of shapes. Works pretty good as well. Calculus is the mathematics of change. But what if I want something that groups all of those together? How can I define that? You might think that was the foundation. No, there's a further, lower level. What's the basement foundation laid upon with? What is all of the math? This one has been quite the puzzler for me for some time. And one of the reasons I had you read that Mathematician's Lament over the break is because when I first read that, that changed my thinking of math quite drastically. I was like, oh shoot, this is more than a list of things to memorize in school. Right? If that's how you thought of math so far, here's just this fact, here's the Pythagorean theorem, I just memorize it and I just use it, right? Here's the area formula, I just memorize it and I just use it, right? Here's the function, I just memorize it, I just use it, right? It's not a list of things, right? Some people have said math is a science. Okay, it doesn't help. It doesn't look like biology or chemistry. So what is science at its essence? Science is from the Greek word of knowledge. It's the pursuit of knowledge. Specifically new knowledge, right? If you just go to the library and read stuff that people already know, but it's new to you, that's not doing science. Science is uncovering something new. Okay? It's objective. It's acquiring knowledge. Here in the gray is my initial thoughts, and then I came across another source that gave these definitions here in blue, and I thought those are much more straightforward and allows a better contrast between science and art. Right? If science is the objective acquisition of knowledge. Gaining, obtaining, uncovering, or discovering, however you want to think about it, new stuff. Art is making creative combinations of those things. It's taking what you already know, putting it together, dressing it up in a new way. Okay? No artist has invented new colors, right? Generally speaking. They did find new sources of pigments and such, but they didn't invent the light spectrum, okay? Light and color already existed. Artists just found new ways of presenting them on the canvas. New combinations of put a little bit of red here, a little bit of green over there, and the blue up top, and oh, now this guy puts the blue on the bottom. That's a different painting, right? It's subjective. It depends on who's doing it, who's looking at it, and it expresses the knowledge. It takes what you already know and shares it out with someone else. Right? It's up for interpretation. Now, you're probably used to mathematics not being very interpretive. It's fact-based. It has a correct answer, right? It's right or it's wrong. And for some people, they love that part. They hate English classes like, I don't know, the teacher grades it's kind of arbitrary, you know? Your essay is either good or it isn't. But in math, you definitely have the right answer. You know when you have the right answer, or you don't. And it's very clear, cut and dry. And the Mathematician's Lament, the article you read over break, talks about how we kind of miss out on the artistic part of math in school. There is an artistry to it. There is an expression, a creativity of ideas. Hey, geometry is fantastic for that, because we can put all these shapes together in different ways and make new pretty pictures out of them, right? I can draw a basic triangle, right? Or we can draw more triangles. And we can stick those triangles together and make some cool new thing, right? And I could keep going and adding on new triangles and create new designs, right? That's art right there. So math has to allow for that. Our definition has to incorporate this concept, being able to create things, new combinations, right? New thoughts have to exist within this universe. And so that's why I have come to the conclusion that math has to be both. It is a science. There is a pursuit of knowledge. Much of it has already been done, right? A lot of in-school math class. Okay? Math class is not mathematics itself, because the mathematicians back in the day, they already did that part. They explored, they find out. They asked the question, what if this happens? What if I take these numbers and add them together? What if I take these variables and add them together? Then what happens? Oh, what if I multiply them together? Then what happens, right? They tested all that. They found it. They figured out what happens, and now we're learning what they already discovered. They did the science part. So in effect, we don't have much of the science aspect in math class either. They did a lot of the putting new combinations together. They created a lot of the math art already. We don't have a lot of that. Very rarely in math class are you allowed to just put things together in whatever way you want, right? Again, there's always a right answer and a wrong answer. Very few questions in math class are open for interpretation, allow you to say, well, I'm going to put a bunch of sevens together, see what happens. Right? I'm going to put a bunch of triangles together. No, I like pentagons, right? I want to try to introduce more art into math class, and not literally making art, not having you draw or paint something, but combine things together, play with math. And that brings me to my last one. Yeah, science and art is a form of expression. And if art expresses ideas, it transmits an idea from one to another. We came up with a better version of that than just cave paintings, right? We have language. And mathematics is also a language, a specific type of art, right? It's a way of communicating ideas. It's an agreed upon lexicon. We don't just make up stuff and say, oh, that's pretty, and move on with our lives. No, no, no. We're going to say that has meaning. And we're all going to agree that it means the same thing, right? When I write out y equals mx plus b, we all know we should at this point, know what that means, right? What do each of these symbols represent? The order in which I write them is important. If I put the M over here, that means something different, right? So there's a vocabulary, right? There's shorthand. There's a grammatical structure to it, and then you have an order of things, and a 2 in front of here is different than a 2 and when it's a little bit smaller, right? We have those kind of grammar rules to it. I've often wondered to myself, would it be more beneficial to teach mathematics as a language, like we do foreign language? Should we have vocabulary tests, grammar, rules for math? What would a spelling test at the end of the week look like in a math class, I wonder? But it's a way of communicating ideas, right? Math itself, okay? It has a nature. It's a study of ideas. I'm going to get to that one-word group of those ideas in a moment. But it's also the expression of those ideas. So I had to have 2 definitions of math. One was not enough. Here's what I've come to. Math is the study of structure. Study of structure. So if you're talking about what is the nature of mathematics as a discipline, okay? If someone is a mathematician, what do they study? Right? Just like a physicist studies physics, well, what is physics? Well, physics is the study of the universe, or be more specific, motion of matter and energy, right? Chemistry, study of molecules and atoms. Right? Biology, the study of life. One's pretty straightforward. Right? Mathematics, so I want to encompass all of those and still be able to apply it to other things. The study of structure, right? Think about chemistry. You could study chemistry by just, combining things together. Oh, let's see. Right? Ask the good old scientific what if. What if I poured this chemical into that chemical? See what happens, right? Will it explode? Will it change color? Will it melt your face off? Who knows? Let's find out, right? It's cool. It's got flashy expositions. You can do the same thing with math. We can take all those concepts of numbers and quantities and shapes, combine them in new ways, see what happens. But we can also take those structures, right? Those numbers, those quantities are structures, those shapes are structures, and we can apply them to chemistry itself. Oh, now we can measure. We can say specifically, if I pour a little bit of this chemical into a lot of this chemical, I get one thing. If I put a lot of this one into a little bit of that one, something else happens, right? So now all of a sudden quantity is important. Shoot, I just imposed the math onto the chemicals. I applied a structure to it, and now I have rules that I can follow to better predict what's going to happen. It's useful that way, right? And even math itself. We said algebra was relationships. Algebra is the mathematics of relationships. I was really tempted to say, well, all of math is about relationships. A triangle is a relationship, isn't it? It's how 3 segments can relate to one another, or 3 angles being brought together. That's a relationship. It's a connection between things. But that's too general. Everything is a relationship, right? English class studies relationships, the relation between words, the relationship between sentences that form paragraphs, right? The relationship between forms of communication, that's English class. History is all about relationships between peoples and people groups, right? So I can't just say math is the study of relationships, because that's basically everything. But math is the one that imposes rules and structure to those relationships. Math is the one that sets it up and says, no, this isn't just, this is bigger than that. We're saying exactly how much. See the difference? It imposes the structure. It creates a structure, right? Rules create structure, and structure has purpose. Structure is important. It makes a difference. Some people don't like the rules in the classroom. You can't chew bubble gum. Don't talk out of turn. Sit in your seat. Why do we have those rules? Because it creates a classroom structure. The structure that serves the purpose of learning. The classroom is designed to learn. So the rules impose a structure that is better suited for learning. Right? What about a physical example? How about this? Why is it that houses here in the northern half of the country all have sloped roofs? Houses down south can get away with flat roofs. Okay? Why did the natives in New Mexico built the Pueblo buildings? Why did they feel they didn't have to put a slope on their roof? They had a nice flat roof. Here is mathematical structure in action, brought to life in almost a pure form, not applied to some other discipline, but architecture is math, it's structure in the real world, in 3 dimensions, right? What's the purpose of a sloped roof? Seriously, answer that. Go ahead, send me an answer. Like, why would you not want to have a flat roof here in Illinois?
Because it rains a lot, the rain can get trapped in the roof.
Yeah, because of the rain, or even worse, the snow, right? You need all that precipitation to fall off. In New Mexico, they don't get much rain. They really don't get much snow, right? They're not worried about that. That's not a problem. They can have a nice flat roof. It's way easier to build a flat roof, okay? If you tried it in Minecraft even, you'll know, okay? Slope roofs are a pain, but they're super useful. They serve a purpose. Like, hey, we need this thing in the world to solve this issue. That is a structure. Literally, physically, a structure. Math is the study of those structures. If you study physical structures in the real world, that's architecture. That's a very math-heavy kind of discipline, right? If you impose that structure on some other topic, right, you can apply math to just about anything. But the term mathematics is not just the study of the structures themselves, but also, right, just you look up any word in the dictionary now, and it's got multiple definitions, right? If I just say math, am I referring to the ideas discovered, or am I also referring to the language to describe those ideas? Mathematics, as a term, also should include all that vocabulary, slope, lines, planes, shapes, numbers, all of those words, right, is the language that we use to describe these structures. Okay. That's what I've come to. And I hope that this helps set the stage, as it were, makes things a little clearer of, like, why do we have all this? How does it all fit together? Right? This is your foundation. This is your canvas onto which now you can map all of the ideas in math class and how they relate to each other. Start forming those connections in your brain. The more combinations you have, the faster you'll be able to solve problems going forward. Okay? Any questions from you?
No.
No? All right. Well, thank you very much for listening. You have those 6 discussion questions. What is math? Purpose of math? Is it a science? Is it an art? Is it a language? Answer those for me today. Give me as much detail as you can. You can reference things from that Mathematician's Lament, the reading. You can mention things that I brought up here today. Bring in some of your own ideas. What do you think of all this? I want to know. Don't just regurgitate the facts that you heard from me. Give me your perspective. In fact, what I want to see from within your answers, put somewhere, either in your answer to, is it science or is it art, or somewhere at the bottom, what is it more of? That's a more interesting question. If math is a combination of art and science, what is it mostly? Is it 50-50? Is Is it 70-30? Is it more science? Is it more art? What do you think? Well, that's an interesting question all by itself. Okay? So include that within your answer somewhere. Your opinion there. I don't know if there's an answer to that. I don't have a fact. Is there a right? Is there a wrong? We'll find out. Okay, so we've got 6 more minutes here in class for you to finish those. That's your only task for today. There are no additional exercises tonight. So when you're done with that, you are done. Turn it in.